Welcome everyone. We're going to start to get into some new topics, and that's going to be carbohydrates, essentially the type of carbohydrates and the pattern of carbohydrate consumption, meaning what you should consume before exercise, during exercise, and post-exercise. Today's lecture we'll talk about the type of carbohydrate and what you should consume 3 to 4 hours before an exercise bout. So if you look at the type of carbohydrates, essentially, we have carbohydrates that come from diet. That's exogenous carbohydrates. Like, for example, if you drink Gatorade, or endogenous. That's where we break down our own glycogen stores for energy. So if we look at how carbs are found in the diet, we see they can come as free monosaccharides, like glucose, fructose, galactose, or you could have disaccharides like sucrose, which is table sugar, lactose, and maltose. Or you can have oligosaccharides, 4 to 10 units, or polysaccharides, which are more, 11 plus. Okay, so essentially, the ability of the intestine to absorb a carbohydrate can be the rate-limiting step for its delivery to muscle cells for fuel use. So that's very important. So the intestinal transport of sugar essentially can become actually saturated, resulting in malabsorption of carbohydrates. So my main point is that oftentimes, if you go back to our first lecture on carbohydrates, you know that that blood glucose levels are important for maintaining endurance performance. So what is going to allow you to oxidize carbohydrates is going to be the rate you can deliver carbohydrates. And if your transporters are essentially saturated, that's not going to happen ideally. Let me show you what I mean. If you consume carbohydrates, one thing you notice is that glucose and galactose are transported by sodium-dependent mechanisms. Okay, so here we see they're transported by a sodium-glucose-linked transporter. Fructose, on the other hand, is transported into the enterocyte by GLUT5 receptors. So what does this mean? What it means is that if you take in 2 substrates instead of just one, meaning like a glucose-fructose combo, you're going to be better off than just taking glucose alone. So as far as how carbohydrates are metabolized, you know that glucose and fructose are going to enter into the glycolytic process. So fructose will enter in lower in that process, glucose will enter at the top. Once you go through glycolysis, you're going to convert over to pyruvate. That's going to go through the Krebs cycle, and finally the electron transport chain where we derive energy. So today we're going to talk about what you should consume 3 to 4 hours before exercise. One thing to know is that when you're done with an overnight fast, you might deplete liver glycogen by 50%. Not muscle glycogen, but liver by 50%. So it could be that a large bolus of carbs could help replenish liver after an overnight fast. And one thing I want to show you here is this. This study, basically what you're looking at on the graph on the left is starting glycogen levels, okay? So one group consumed 140 grams of carbs 4 hours before exercise, and it was a 105-minute bout at 70% VO2 max, or they consumed water. Notice that the carb group had higher starting glycogen levels than the fasting group. However, their final carbohydrate levels after the event was no different. But if you look over to the right at the respiratory exchange ratio, remember, the higher the respiratory exchange ratio, the more carbohydrates you're using. The lower it is, the more fats you're using. So essentially what you can see is that you're using more carbs in the fed than fasted condition, indicating that you're essentially increasing your rate of carbohydrate use. Now, other studies have looked at the impact of low carbohydrate, 0.6 grams per kilogram or 50 grams, moderate carbohydrate, 2 grams per kilogram, and high. So if you look at these graphs, and this is 4 hours before exercise, if you look at these graphs, you can see essentially something very interesting pops up. This is fatty acids in the blood. Notice that this is the fasting condition I'm pointing to. Fatty acids are much higher in the blood in the fasting condition. The one with the lowest condition was the 312 gram carb one. And if you look at respiratory exchange ratio, with the 312 grams of carbs, you're using maximal amount of carbohydrates, whereas you're using a maximal amount of fat with the low carbohydrate and placebo conditions. Now, what they did after they gave these carbohydrate sources, they had individuals do a real long race. So, essentially, this was, again, a very long race. So, and what they ended up doing was they exercised for 95 minutes at 55 to 75% VO2 max, and then they did a time trial. Okay, so this is obviously longer than 90 minutes. And if you look here, the fasting condition, the 50 carb condition, the moderate carb condition, which is like 150 grams, versus the high condition, 300 grams. The 300 gram condition actually did cause a 15% improvement. So for events lasting greater than 90 minutes, it could be beneficial to have high amount of carbs. This is a good study that essentially looked at time to exhaustion, and time to exhaustion is essentially how long you can go on the treadmill before falling off that treadmill. In this case, it's 70% VO2 max. Notice when you had 100 grams of carbs 3 hours before exercise, that your endurance capacity measured via the time to exhaustion trial was greater. So if we were to sum this up, we would say that ingestion of a carbohydrate-rich meal after an overnight fast 2 to 4 hours before an event is important for events lasting longer than 90 minutes. But again, that's if you're running a race. If you're doing normal training 4 to 5 days a week, it's doubtful this is necessary. However, if you're training greater than 90 minutes a day for 6 to 7 days a week, high intensity, it may be necessary on a regular basis. So the next topic that we have is glycemic response to carbohydrates. Essentially, when you ingest carbohydrates, it affects both blood glucose levels and insulin levels. Okay, in general, a high blood glucose response equals a high insulin response. Okay, so that's very important. Now, if you have a high insulin response, that's going to affect the energy sources you use during exercise. So many of you have heard of glycemic index, but essentially it's based on a scale of 0 to 100. So white bread's 100. So a high glycemic index, blood glucose rises up fast, whereas a low glycemic index, it rises up slowly and it's more prolonged. Now, glycemic load takes into account both the glycemic index as well as the amount of carbohydrates per serving. So, for example, both carrots and pasta have the same glycemic index of 47 to 48. However, there's only 5 grams of carbs per serving in carrots and 40 grams of carbs per serving of pasta. So you notice the glycemic load is essentially calculated via carbohydrates, the glycemic index times the amount of carbs per serving divided by 100. So we see 19.2 for the pasta and only 2.4 for the carrots. So we're basing things on glycemic index. A low is going to be 0 to 55, intermediate 56 to 69, high greater than 70. For glycemic loads, 0 to 10 is low, intermediate is 11 to 19, high is greater than 20. Foods that typically have high glycemic loads are like your breads, your pastas, your rice. sweet corn, corn flakes, things like this. However, vegetables, on the other hand, and beans, on the other hand, tend to be of the lower glycemic load persuasion. One of the things I want to point out is that you can't look at carbohydrates in isolation unless you eat them in isolation. So a baked potato has a high glycemic index, which you can see on the upper graph there. So does pasta, you see on the lower graph. When you add cheese to that, it makes it low glycemic. So just remember, a mixed meal changes the dynamics. So a lot of scientists have proposed this, that if you consume a low glycemic index carbohydrate, that you'll have lower insulin levels, which means you're going to use more fat as fuel during exercise because insulin impairs your ability to use fat. Thus, you'll spare more glycogen, and you'll be able to train longer. So that's one of the things, is essentially allowing you to use two fuel sources, whereas high glycemic arrests you to one fuel source. So theoretically, it could help performance. Okay, so what they did here is they had breakfast given 3 hours prior to training. They had a high glycemic index carbohydrate versus a low. And one thing I want you to notice, you look at the high glycemic index carbohydrate pre-exercise, which was post-meal, they have higher starting glycogen levels. Okay? However, at the end of the race, their glycogen levels are the same. And the reason why is because the high glycemic index carbohydrate increases the rate of glycogen usage. So at the end, you still have the same amount of glycogen. This is a real classic study, actually, and what they found was that a low glycemic index condition improved time to exhaustion trial at 70% VO2 max. And one of the things I want to point out, because a lot of people are interested in fat metabolism, if you look at our graph to the right on fat oxidation, essentially what's going on is you notice that fat oxidation is much higher when you have a low glycemic index carb, that's the white circles, the clear white circles, versus the black circles, which is high glycemic index. So if you're interested in fat oxidation, it's going to be improved by a low glycemic index food. We can see this here. The black is low glycemic index carbs, the white is high. And what you can look at during the exercise time, you see non-esterified fatty acids in the upper left. And you can clearly see that there's higher fatty acids with the low than the high. Now, why is this important? They gave this the day before they trained. So not just 3 to 4 hours before, but the day before they trained. So what you eat at night could program your metabolism for your morning training session. What's also interesting is that the fat that was used in the high glycemic was primarily intramuscular, whereas the fat that was used with the low glycemic was a combination of intramuscular as well as from adipose tissue. So for fat metabolism capacity, you're using more fat and a higher percentage from adipose. So essentially, low glycemic versus high glycemic carbs given the day prior to or the day of exercise appear to affect metabolism. And that causes an alteration in glycemic, insulinemic, and lipolytic responses during exercise. As a result, the rate of carbohydrate oxidation after pre-exercise CHO ingestion is influenced by the glycemic index, with the ingestion of low glycemic index food providing a more stable metabolic response. However, one thing that I do want to point out is that if you have a high or low glycemic index carb, what this study is showing is that if you consume carbs during exercise, it doesn't make a difference. Okay, so there's no difference in oxidation of fat or carbs when carbs are consumed during exercise. So if you have high or low glycemic index carb, and you have carbs during exercise, it really doesn't make a difference. Where high versus low makes a difference is if you're not consuming anything during exercise. So again, when glycemic index is looked at itself, the low glycemic compared to high glycemic increases lipolysis and fat oxidation at rest and during exercise or both. It decreases the use of intramuscular glycogen. However, high glycemic index and high amounts of carbs increases resting glycogen levels. However, because the rate of glycogen depletion is increased, at the end of the race, levels are similar. Thus, low glycemic index carbohydrates could be good for fat metabolism if this is the goal. However, research also shows if CHO is consumed during exercise that glycemic index does not impact performance. So here we see, this is how we look at the pattern of exercise: last meal before exercise, nutrition during exercise, nutrition immediately after, and then in the second phase. So one of the things to realize though is that if you do a short duration, higher intensity race, like less than a 10K, glycemic index is not going to really matter that much because glycogen is not going to be limiting. It doesn't matter if you're using fat or carbs. However, when you're performing like a lower intensity event that's greater than 2 hours, low glycemic can be important. In no case has high glycemic been shown to be better than low glycemic unless the low glycemic has a negative effect on gut. Notice that these results are based on studies consuming no food during training, where you see differences. And that's the end of the lecture. Thank you again for your time, and I'll see you next time.